Hello friends, today in this session we will discuss oblique planes. In my earlier lectures I told you about auxiliary planes. Auxiliary horizontal plane which we call inclined plane and auxiliary vertical plane which we define like this by their VTH. When vertical trace is inclined to horizontal plane and horizontal trace is perpendicular to the ground plane, then it is inclined. And when vertical trace is perpendicular to ground line and HT is inclined, then this is A. And I told you alpha and beta are the angles made by these planes with the reference planes. And I also told you about the third plane. This is the profile plane, a special case of IP or ABP when this plane becomes perpendicular to both the reference planes and therefore VTH will be a line perpendicular to ground line. There is another plane which is slightly complex in nature and that we call the oblique plane. Oblique plane is inclined to both the reference planes, horizontal plane as well as vertical. This is oblique plane. Oblique plane inclined to both the reference planes and therefore VT and HT both will be inclined to ground line. That is the oblique plane. And this angle will depend upon the inclination of the plane with the reference plane. This is not real angle and therefore we denote it by eta, and this is also not the real angle made by the plane and therefore this is generally denoted by zeta. Eta, zeta are the angles made by the traces in the ground line. Alpha, beta are the angles made by the plane with the reference plane. And alpha plus beta cannot be more than 180 degree, and it is 180 degree when the plane is profile plane, when alpha and beta both are 90 degree. It is always more than 90 degree. It cannot be less than 90 degree. And 90 degree is when the plane is perpendicular to either horizontal plane or vertical plane. In that case, beta will be 0 or alpha will be 0. Now this is oblique plane. Oblique plane when VTH is inclined to both the reference planes. Now, when you know the oblique plane, how do we determine the real angle of the plane? Then there is another case of an oblique plane where alpha plus beta is 90 degree. Say for example, this plane, which is placed between horizontal plane and vertical plane. This plane is also oblique plane because it is not auxiliary plane. Here alpha plus beta is 90 degree. This is angle with the vertical plane, this is the angle with the horizontal plane. So you can say this is alpha, this is beta. And vertical trace and horizontal trace both will be parallel to ground like this, VT and HT. How do we find angle made by this plane with the reference planes alpha and beta? And to understand that, let me just explain to you what is the meaning of angle between two planes. Say you have two planes here, plane 1 and plane 2, and they are inclined. They are not reference plane, they are any two planes. Any two planes, let us say one is horizontal and another one is inclined to this plane. Now to find out the angle between these two planes, we will take a plane which is perpendicular to both of them, and then these planes will project as two lines, and the angle between those two lines will be the real angle. So what we do, practically you draw a line here in plane number 2, let us say AB. You draw a line AB in plane 2 which is perpendicular to this intersecting line. Let me call it horizontal trace, or you can call it XY. So I draw a line AB in plane number 2 which is perpendicular to horizontal trace, and find out its projection on the plane number 1. Its projection on plane number 1. Let us say this projection. A is in this plane. So this is, let us say, C. This point C. Then in that case, this is the true angle alpha between these two planes. You can imagine a set square. You can imagine a set square with longest edge in the plane number 2, the shortest edge in plane number 1, and this is vertical. And in that case, this angle is alpha. So that is the meaning of angle between two lines. So whenever you find angle between two lines, take a line, draw a line in plane number 2 perpendicular to the intersecting line. So here, if you want to find out angle between this plane, now this is plane number 1, B, plane H, and this is plane oblique O. 1, 2, 3. Now let us find out angle between plane O and H. So this is plane number 1, this is plane number 2 now. So you draw a line in plane number 2 which is perpendicular to intersecting line HT. So we draw a line. We draw a line in plane number 2 perpendicular to HT. Let us say I keep it A, B. Now remember, A is in vertical plane, and therefore its line will be on the ground line. So here is the plan. Let us say call it C. B is in horizontal plane. This is the projection, the plan, and therefore in that case this will be the true angle between the two planes. Right? Now because this is a special case when alpha plus beta is 90 degrees, so beta can be measured here. Beta can be measured here. Now take this case to this case. You have a point A on vertical trace. So take a point on vertical trace A. AC is perpendicular to ground line. AC is perpendicular to ground line. CB is also perpendicular to horizontal trace. So CB is perpendicular to horizontal trace. Now this is the triangular plate ABC. An angle made by this plate at C is angle made by this plate at B is the real angle. Now how do you get this angle? To get that angle, what we do, you rotate this plate about this side AC, vertical side AC, and bring it in the vertical plane, so that you can measure this angle at B in the vertical plane. So what we are doing, when you rotate this plate about AC, this point C will rotate about B. So in projection, this point B will rotate about C. So take C as center and rotate this point to the ground line. This becomes, let us say, B1. Now this is a true angle. This is now the true angle alpha. You can rotate this side, you can rotate this side also. Okay. And this is beta. That is the basic principle of finding angle between two planes. I again repeat, draw a line in plane number 2 perpendicular to intersecting line and draw its projection. Projection is B and C. Then angle between true length and its projection on plane number 1 is the true angle. That is the case. Now let us take a general case when alpha plus beta is more than 90 degrees. Let us say you have an oblique plane which is shown by VTH in projection. VTH are known. Problem is to find real angles. So again what we do? Let us find first angle alpha. So alpha means angle made by this plane with the horizontal plane. So this is the intersecting line HT. So you draw a line here perpendicular to HT. Let us say AB. Okay? Draw a line AB in oblique plane. That should be plane number 2. Now this is plane number 2, plane number 1. So in plane number 2 you draw a line AB perpendicular to intersecting line. And get the projection of this line on this plane. Now this is the point in horizontal plane, so this is the plan itself, and with the point in vertical plane, so its plan will be here on the ground line. Let's say this point is C. So in that case, this is the plate now, and this angle is alpha. So you have placed a plate in such a manner that this edge is perpendicular to HT. This edge is vertical and this AB is in oblique plane. That plane will give you angle alpha. So come to this figure. Take a point A on vertical trace anywhere. AC perpendicular to ground line. BC perpendicular to horizontal trace. You get this triangle. And again, to measure this angle alpha, you rotate this plate and bring it in the vertical plane. So rotate this plate about AC so that B comes on the ground line here. Then this is the plate. Let us say this point is B1. Then you can measure this angle alpha here. Alpha. So C as center and CP as radius, you rotate this point and bring it on the ground, either this side or this side. This is the angle alpha. Angle alpha. B1 or B. That is how you find angle between oblique plane and horizontal plane, angle alpha. Similarly, if you want to find out angle between this oblique plane and vertical plane, then this is plane number 1, plane number 2, and then the intersecting line. So in that case, you take a line which is perpendicular to vertical trace. Let us say E, F. Let us say E, F. Its projection on vertical plane now. Okay, so this is a point in the vertical plane, and its elevation will be somewhere here on the ground line. Let us say D. Okay, let us say D. Then this is the plate. This is the plate. This is the plate in the oblique plane and vertical plane. And it will give you true angle now. Okay? True angle here between the line and its projection on the vertical plane. Angle E, angle F, E, P will be the real angle beta. So let me take another diagram. This is the vertical trace, horizontal trace. Start from here now. Take a point F on HT, a perpendicular on ground line, which is D, a perpendicular on vertical trace, this is E, and about, again, now rotate. Now rotate this plate about this side, DF, so that it comes in the horizontal plane. angle beta in the horizontal plane. So rotate E about D and bring it here. Let us say E1, or you can do it this side also. This is angle beta, or this angle beta. That is how you determine angle made by an oblique plane with reference planes once you know the VTH. And principle is same, that you consider a line in the oblique plane perpendicular to intersecting line with the plane. Now, if you look at these two figures, you can join these two figures together. You can determine alpha beta in the same figure. Now, consider a cone. Consider a cone which is cut vertically in two parts. Half cone. Consider a cone and place that cone in the horizontal plane. So, in the horizontal plane you see half circle, and in the vertical plane you see a triangle. Similarly, this is another cone where the half cone where you have placed in the vertical plane, and the plan is a triangle, and vertical trace is tangential to this cone. Horizontal trace is tangential to this cone. These two cones have different spheres. Diameters are different. Okay? When you combine these two figures, it is like this, that you have an oblique plane, you take a point A, B, C and rotate it to C1. This is angle alpha. You take a point D here, E, F and rotate it to F1. This is angle beta. That is combined figure. Okay, that is the vertical trace and horizontal trace. Now, this vertical trace is tangential to this half circle and horizontal trace is tangential to this half circle. You can redraw this figure by taking these points A, B and E, the same point. Okay? Let us say this is A, this is B, and this is the perpendicular, this is the point alpha. This is the point D, and this is the perpendicular, and this is point F1. This is angle beta. Now, this is the procedure of drawing the vertical trace and horizontal trace when alpha beta are known. Reverse of this process, reverse of this method is the method of plotting vertical trace and horizontal trace when alpha beta are given. Here, the unknown parameter is alpha beta are known, but unknown parameter is what is the radius of this semicircle and what is the radius of this semicircle. So, as a first step, let us assume that these two radii are same. So, take a ground line and draw a circle of any radius here. Any radius. Take any point on the ground line and draw a circle of any radius. And initially assuming that these two have the same radius. Okay? Now, take a diameter of this. Let us say this point is B. This point is B. You can name A also. Now, alpha and beta are close. So, draw a tangent to this circle at angle alpha in the vertical plane. At angle alpha. This point, let us say, is A. This point is now on the vertical trace of the oblique plane. Okay? This angle is alpha. So, this alpha takes you to vertical plane. Okay, and this is the radius of the lower semicircle. This is the radius of the lower semicircle. Draw another tangent here at angle beta. Let us say this point is, you can say E. Okay. Now B as center and this as radius. Let us say C. This as radius BC. Draw a semicircle in the lower part of the, or you can say in the horizontal plane. And similarly, B as center, and let us say this point is F. B F as radius, you draw a circle in the vertical plane. Now you got circles, or you got the radius of two cones, one in the horizontal plane, one in the vertical plane, and this is a point in the vertical trace. So from this point you draw a tangent to this circle, and from this point you draw a tangent to this circle. They should meet at the same common point on the ground line. So if you draw a tangent from A to this semicircle and a tangent from E to this semicircle, they should meet at T on the ground. This is the vertical trace and this is the horizontal trace. That is the method of locating traces when alpha, beta are known. This is beta. Okay, this one is beta. This is called the cone method. So here you are considering two cones, one in the horizontal plane, one in the vertical plane. There is another method of drawing these vertical trace and horizontal trace, that is called perpendicular line method. Perpendicular line method, basically you consider a line which is perpendicular to this oblique plane. So if oblique plane makes alpha beta angle with the reference plane, line will make angle theta, which is 90 minus alpha, and phi, which is 90 minus theta. Because line is perpendicular to oblique plane, so line will make angle theta with the horizontal plane, which is 90 minus alpha, and phi will be 90 minus beta. And one thing also you should remember, that when a line is perpendicular to a plane, its projections are perpendicular to traces of the plane. And therefore, if you draw the projection of this line, which makes angle theta and phi with reference planes, you can draw traces of this plane also. So take any line, let us say a line AB, you can assume 100 millimeter long, make it theta, 90 minus alpha is known, and phi with the reference planes. You draw projection of this line, and I explained this projection of lines in another session. And let us say you get projection of the line like this. Because angle does not depend upon the length, so you can take any length. Okay, and you can also take the first point or A at any height, any distance from vertical plane and horizontal plane. And let us say you get the projection of this line, which is inclined at theta and phi reference planes. Now, you draw a line perpendicular to elevation, at any point. Okay, you draw a line which is perpendicular to this elevation, that is vertical trace. And from this point T, you draw a line perpendicular to plane, that is horizontal trace. A simple method. When line is perpendicular to a plane, its traces will be perpendicular to projection of the line. So that is another method of determining traces of an oblique plane when angle alpha beta are known. Now here you have four angles. Angle made by the vertical trace and horizontal trace, that we call eta zeta, and actual angle made by the plane alpha beta. If any two are known, you can determine the remaining two. So for example, let us say that HT of an oblique plane is given. HT makes some angle and plane makes alpha with horizontal plane. Draw vertical trace. That's the question. Now when HT is given, alpha is given. It can be HT and beta also. It can be BT and alpha also. It can be BT and beta also. I am just taking one case. You can solve remaining 3 cases yourself. So when alpha is given, just recall the method of finding alpha. How do we find alpha when VTS is given? We find alpha by this method. Okay. What we do? We take a plane, we point here, B, C, AB perpendicular to ground line, BC perpendicular to horizontal trace, rotate this point C about B, and you get a point C on the ground line, and that is angle alpha. Now here, HT is given. Okay, HT is given. So draw HT first at given angle. Take a point here, any point C, take perpendicular to this, you get B. Rotate this point B about, rotate this point C about B and bring it on the ground line. That is point C1. At this point, make angle alpha, which is given. Alpha. From this point, raise a perpendicular. That is the point A, and this is the vertical trace. This is now the vertical trace. So when data are given, you should recall the method. How did you determine angle alpha when VTH was given, and follow the reverse procedure. Right? So remaining 3 cases you can solve yourself. Although there are many cases of oblique plane which you can observe in nature, but it is not possible to draw projection on oblique plane directly, and therefore we always take help of either inclined plane or auxiliary vertical plane. And I'll tell you how we convert an oblique plane into an inclined plane or into an ABP. Let us say we have an oblique plane VTH and we want to convert this into inclined plane. So what we do? We take a plane here, perpendicular to this plane. This plane. I have taken a plane which is perpendicular to horizontal plane, perpendicular to horizontal trace also. Perpendicular to horizontal trace means this plane will now be perpendicular to the oblique plane. But this is not the reference vertical plane, and therefore it is auxiliary vertical plane, A. And now you consider, forget about this vertical plane, you consider this horizontal plane and this auxiliary vertical plane. This oblique plane is now inclined to horizontal plane and perpendicular to this ABP, because we have taken ABP perpendicular to oblique plane. And you remember a plane which is like this at angle alpha. This is IP. A plane which is inclined to horizontal plane and perpendicular to vertical plane. This also a plane. This is also now a plane, oblique plane, in reference of this HT and this ABP. It is inclined to vertical plane, and this is inclined to horizontal plane and perpendicular to ABP. So you have to just simply get this intersecting line, which will be the vertical trace, a new vertical trace of this plane. Now this new vertical trace will be simply projection of this VT on this ABP. So you project this line VT on this ABP. So what we have done, we have taken a plane in case of if you are given an oblique plane BTH, take a plane which is perpendicular to horizontal trace, and this plane is ABP. You can take here, you can take here also, doesn't matter. And now project this line BT on this A. And to project a line you need 2 points. Let us say the first point is this T, which is on the ground line. So its position will be here. Take another point anywhere on the vertical trace, let us say A. Its plan will be here, B. A is in vertical trace, A is in vertical plane. So plan will be the ground line. Okay. So from this plan, if you draw a projector and take distance of this elevation here, you get A1. We join these 2 points. This is the new vertical trace, and horizontal trace remains same. Now you compare this case with this case. The ground line is now x on y1. Vertical trace is inclined, and HT is perpendicular. So this becomes inclined plane. You can measure this angle alpha. This line can proof. That is how you convert oblique plane into an IP. Similarly, if you consider another plane which is perpendicular to this vertical trace, perpendicular to vertical plane, that will be inclined plane, and project horizontal trace on that, you can convert this into ABP also. So if you take a plane here x2 y2, and project this horizontal trace on this plane, and for that again let us say the first point is T, this point is the T on the ground line. Take another point here, project it, take this distance above ground line, join these two, you get a new horizontal trace. Vertical trace remains same. Vertical trace remains same, and this angle will be beta. Real angle made by the plane. Conversion of oblique plane into IP or ABP is extremely useful when you project points, when you determine distance between a point and a plane, or when you project lines on that. So friends, thank you very much. We stop here today. I have covered the normal cases of oblique plane, how to draw BTH, how to determine angle between 2 planes. In the next lecture, we will discuss some complex cases of oblique.